Hello and welcome to yet another session of GDG Tech Sessions. My name is Rustam. I am with GDG Cloud Oslo, and it's my great pleasure to welcome you all here at GDG Tech Sessions. So today we're doing this event as a little bit different. So it's a little bit different than what we've done before. So this is an it's under the Chrome Dev Summit extended program. So today we're going to be having a really exciting talk about progressive web apps, and yeah, this is part of the Chrome Dev Summit extended edition. So before we get started, I think I'll say a few words about what we do here at GDG Tech Sessions. So in 2020, so last year, we had quite a few sessions. We had 10 sessions about different topics. It's a quite a wide variety of topics, as you can see here. So it's anything from Firebase, GraphQL, web stuff, and Android, and data pipelines. It's been a really interesting and exciting mix. And we do publish everything on our YouTube channel, where you're probably watching that as well. So make sure that you are subscribed to our channel. So click subscribe and the bell button, and you know the drill, right? So do all that because we'll be publishing a lot of new and exciting topics and talks this year as well. So I think it's about time to introduce our speaker of the day. So that's Tamas Piros, and he'll be doing an introduction to PWAs, or progressive web apps. A few words about Tamas. So he's a fellow GDE, Google Developer Expert for web technologies, and he's also a seasoned Developer Evangelist. He is passionate advocate for modern web technologies, helping people to understand and unlock the latest and greatest features of web development. And this is really cool. So I'm really excited about today's talk, and I think I will actually switch to Tamas. Please join us.
Yes, hello.
Welcome. So
Thank you.
A very short introduction of you, and I think I will leave the stage to you very soon. And one last thing that I would like to say is that folks, please type your questions in the chat window. We will see them. We'll show them on the screen. I'll read them aloud, and then we can talk about that, and Tamas will also answer that as well. And yeah, that's pretty much it. That's, I think, all we need to do, and we'll do that at the end, right? What works for you? Okay.
Just let's collect all the questions at the end, and we'll carve some time out to answer them.
Sounds fantastic. So yeah, I think I will disappear from the screen, and I'll leave the stage to you.
All right, thank you. Okay, so I will share my slides. So I'm hoping at some point that's going to appear. And I think you are now seeing my slides. So again, thank you very much for the introduction, and thank you very much for inviting me. It's a great pleasure to be here. And thanks for everyone in the stream for joining as well. So I got a very good introduction, so I'm not going to reintroduce myself to you. Instead, we're going to start talking about what we are all here for, which is PWAs, or progressive web applications. Now, this session is an introductory session, so I'm going to cover the basics of progressive web applications. We're going to go through those via a set of slides, and then I'm going to jump into my code editor, and I'm going to show you a couple of hands-on examples of progressive web apps and kind of functionalities that you may want to investigate and learn about them in the future. So what are progressive web applications? I think the simplest explanation that I could come up with is this one. That is nothing more than just a website that has app-like features. Now, traditionally speaking, if you think about applications, you usually think about it having features such as the fact that you install an application, right? You would go to some sort of an app store to do an installation, or the fact that apps are available offline. So, even if you don't have network connectivity, you can still interact with the application, you can still work with the application. You may not be able to, of course, send data over the wire, but it's still functional. And last but not least, you can always re-engage with applications, meaning that once it is installed on your device, you can just very easily tap on its icon to open it again, right? So it's very easy to re-engage with applications, also via notifications. So a progressive application is a website that has these three features at its core, right? It can be installed, it's available offline, and it's re-engageable via notifications. Now, you can also think of a progressive web app as a hybrid application type, because it's an application that will function both on your mobile as well as on desktop. And what's really important is that when you're using a progressive web application on your mobile, it will feel like a native application. So you won't be able to tell whether that is an iOS app, an Android app, or just a website that now you interact with. And the other benefit for having such a hybrid application type is the fact that you only have one code base, right? So you don't need to have multiple code bases. You don't need one for the web, one for Swift or iOS, and one for Android using Kotlin, for example. You can just create one application that will work and behave very similarly in every single environment that you have. So how does that work? What is the technology that enables us to create progressive web applications? And there are a bunch of APIs that are available inside browsers today, right? So Service Worker and the Service Worker API, the cache interface or the cache API, there's push and notification APIs, and there are lots of additional APIs that are coming. There are that are under development, some that are released in the latest Canary versions of various browsers, or the latest nightly builds in browsers. So do check them out as well. A lot more text on this slide is a link, so I'm hoping you'll be able to access these slides and you can click on that. But there's a lot of APIs, web APIs or other APIs that allow you to create progressive web applications. But at its core is the service worker and the cache interface that enable you to create a progressive web app. So let's talk about the service worker first, because I think that is the most fundamental concept that you need to grasp when you start to investigate what a PW is. So again, very simply put, I like to think of a service worker as a proxy between the browser and the internet. Now, on this figure that you see on the slide, you see that the service worker is sort of separate from the browser. But I just drew this figure in order to make a point. But of course, the service worker is part of your browser. So every time when you open up your browser, you type in example.com, your browser is going to execute an HTTP GET statement to grab that resource from a server somewhere on the internet. Now, what the service worker does, it can intercept that request, do something with it, add to it, remove stuff from it, and then rebuild the request and send that new request to the internet. Now, you have your response, you have your index.html file, for example, coming back from the network. Again, the service worker can intercept that response, can manipulate that response, and then can send the response back to the browser. So it acts as a proxy in between the browser and the internet that allows you to intercept the request and response cycle. So why is this important? It is important because if you combine the service worker with something like the cache API, the cache interface, you can enable offline features, right? So basically, you have your requests going out, And the service worker can, as part of its operation, cache those resources. Now, those resources that you can cache can be literally anything. It can be HTML files, JavaScript, CSS fonts, images, videos, it doesn't matter. And when the same resource is being requested for the second time, or any subsequent times, the service worker has an option that it says, hey, you're requesting this particular font. Let me first check the cache for you. And if it's available in the cache, I'm just going to return that font from the cache, or whatever resource that you're requesting from the cache. And I'm not going to go out to the internet, which means that essentially if you cache all the static resources and all the static assets and some additional assets that make up your application, there's no need to connect to the internet. There's no need to have a network connection in order to be able to build up your application. And this is really the core driver behind the service worker and the cache interface. And this is what makes up a progressive web application, essentially. Now, there are lots of caching strategies out there. So there's cache first, there's tailwire validate, there's network first, and some others. I think there's about 4, 5, or 6 of them. We're not going to get into those, but I highly recommend that you do some research on that as well. So how does a service worker look like? Well, there are a bunch of steps that you need to follow to get up and running with service workers. The good news is that everything is in JavaScript, right? So if you know JavaScript, it's going to be very easy for you to create a service worker. Now, before you get started, the very first thing that you need to do is to register an actual service worker. So in this example, you see that register method, which is pointing to a service worker.js file. That file is your service worker. And what you see here, this couple of lines of code, is what you would have in your app.js or any other JavaScript file executed inside your browser. Now, even though service worker support is very high in modern browsers today, it still makes sense to do a little bit of sanity check and say, if the service worker is available in your browser, then register that service worker. Okay, so registering a service worker is a promise-based operation. All you need to do is just point to a valid service worker file. How does a valid service worker file look like? Well, as I said, it's just JavaScript. And I consider that I am now opening that file to show you what's inside this one. And it's a very, very simple example. In fact, this is the most simple example that I could have come up with to demonstrate what service workers do. So we have an array of files, which is essentially a list of files that make up our application. In this case, the application is very simple. It has an HTML, JavaScript, and CSS file. Then in the next couple of lines, what I'm doing is creating a cache with the name of my dash cache. Okay, so it's just, it's any arbitrary name. You can name your cache whatever you want. Then I'm going to add an event listener for the install event. So essentially I'm saying if the service worker is being installed, which is part of its lifecycle, then I would like to open up a cache, and the open method either opens a cache or creates a cache with the name that you've specified if one doesn't exist. So in this case, we are creating and opening our cache, and we just add all these files to that cache, okay, upon installation. Then I'm adding another event listener for the fetch event. I mentioned that every time you enter something into your browser, the browser will do an HTTP GET request, right, which is done via a fetch event. So you can also add another event listener inside your browser for listening on the fetch event. And the fetch event, in our case, is going to do a match inside assets in our cache. In other words, if we are requesting index.html, for example, which is going to be part of event.request, if there's a match for that inside our cache, which is going to grab that and send it to our browser. Otherwise, you see the double pipe symbol indicating an OR operation, which is going to go out to the network with the regular fetch operation to grab that resource. So effectively, the line that I highlighted here with that arrow is the one that is going to serve up resources if we don't have a network connection. And that's pretty much it, right? That's really the essence of a service worker. And if you've done everything correctly, then you will no longer see the infamous dinosaur, although I hope everyone knows that you can play a game here. So if you see this dinosaur, just press the spacebar and then see what happens. But if you have a progressive web app, if you have the service worker, there shouldn't be a scenario where you're going to see this no internet message, because there's always going to be something that you can serve up from the cache via the service worker. So this sounds great, but there's a sort of warning that I would like to tell you. The service worker API itself is really complex, and there are lots of edge cases that you need to be aware of. So for example, what happens if you have some stale data inside your cache? How do you update that? How do you handle a service worker when you have multiple tabs open for the same page? Like, how do you push a change? How do you check for file changes? How do you make sure that those are going to be made available for all your users? So there's lots of sort of dark corners that you can find, and the larger your progressive web app is going to be, the more complex and more complicated the code is going to be that you need to write. Now, luckily for us, there's an open source JavaScript library available called Wokbox.js, which I like to think of as a sort of wrapper on top of the aforementioned APIs, right? The service worker API, the cache interface, and also many, many other APIs that allow you to create a progressive web app. So basically, all the APIs that you can use to create progressive web apps have a wrapper inside this Wokbox.js, this open source JavaScript library, which is a library by Google, by the way. So with Wokbox.js, and the reason why I really, really like Wokbox is because it allows you to focus and concentrate on creating very, very good progressive web applications, right? As opposed to you having to figure out, how to work with a service worker API, which at this point you could almost consider as a lower level API. And I'm going to show you an example. Now, I give you the code that you see here is slightly more complicated. First, I'm using some modern JavaScript syntax, but with these couple of lines of code, we achieved a lot, which would have been a lot more just using the service worker and the cache APIs. So what we do here, we are bringing in a couple of things from various Wokbox packages, pre-caching, routing, and strategies. I just print out Wokbox is loaded, just a message, and notice that pre-cache and route message there. So remember in the previous example, we established that we need to create a sort of an array to tell our service worker what are the files that make up our application, right? The HTML, the JavaScript, and the CSS. With Wokbox, with that one single line of code, pre-cache and route, Wokbox is going to sort of discover the static assets that make up our application. So we don't need to specify them one by one. It's going to pick up all the HTML, all the JavaScript, all the CSS, all the fonts, and everything else that it can find, and add it to a cache. All of that is done automatically for us. Then with the next 6 lines of code, again, believe it or not, what we do, we essentially go out to that API, which I'm running locally, but you could run that API anywhere. It could be any API out there, a REST API that you use, or any sort of REST API, as I said, out there. And what I do, I essentially cache the response from that API, and I put that into a cache called API-cache. So again, with 6 lines of code, we managed to grab a response from an API and put it in a cache. Why is that useful? It's very useful because later on we can just serve that API response from cache as well. And we're going to see examples of all of these that I'm code samples that I'm showing to you. Here's another example. Again, if you're new to progressive web apps, you may not realize how useful this is, but these couple of lines of code essentially take a look at your application, and they're going to place images, and only images, because we're filtering down using the request.destination option to find images, and we're going to cache the images in a cache name called images Furthermore, we're going to add some strategy to the caching mechanism as well. And we're going to say, we want to store a maximum number of 60 images inside the cache, and we want those images to be younger than 30 days. So it means that if we now have 61 images, then the first one that got added will be deleted automatically. Or if we have an image that has been in our cache for more than 30 days, that will automatically be deleted as well. So this gives you this nice automation for storing the 60 freshest, newest images inside your cache. And again, that's all the code that you need. There's nothing more that you need to add. Okay, so let's also talk about the keywords, or one of the keywords that make up a progressive web application, and that is progressive. And the reason why a progressive web app is called progressive is because it should provide your users with progressive enhancements. Now, what are progressive enhancements? These are sort of options that you can give to your users based on sub-conditions. And these conditions could relate to network connections, a device, whether it's an older or newer device, and stuff like that. So for example, if your user is offline and they are interacting with your application, it would be nice if you could provide them with some visual cues, some visual hints to indicate what they can do or what they can't do within your application if they are offline. If someone is in a 2G or a 3G network, you probably don't want to stream an HD video for them, but try to figure out a way to maybe show them an image instead. So still give them, that sort of visual experience, but try not to use up maybe their entire monthly data allocation because you just decided to stream an HD video for them. And also, what if they have an older device? They would try to load, less functionality, less JavaScript. And then as the network connection changes, as they come online, you progressively enable them, different options inside your application. So this is why we call this progressive. Now, there's one particular chapter on the progressiveness, if that's a word, that I would like to touch upon, which is the visual web. So I don't know how many of you had friends who had cats 20 years ago, but back in the day, people just said, "Oh yeah, I just got myself a cat." Then about 10 years ago, they were posting photos of the cat everywhere. And what people do today is they are posting videos about their cats, right? So there's no denying the fact that the web has turned visual, right? So there's lots of images and lots of videos that we consume. Businesses rely on this to try to sell you stuff. But it's incredibly difficult because there are a lot of image formats out there. There's lots of optimization techniques that you can use. There's usually when I do this presentation or even a workshop version of this, I ask people, who heard about WebP and WebM, and now there's, AVIF and all these other formats. And people heard about JPEG, but not necessarily about WebM, which is, a video format. So managing and delivering all of these in a way that is performant is incredibly challenging. Now, I'm also going to talk to you about a concept here, which, again, I'm going to demonstrate this to you in a couple of minutes when we go hands-on. In fact, I'm going to change in less than a minute, I think. Just imagine that, what if you could serve a different quality image for your users based on the connection that they have? In other words, if someone is using a 3G connection, for example, you could serve them an image that's, say, 6.8 kilobytes. And if someone is on a 4G connection, you could, send them an image which is 9.9 kilobytes. Now, of course, these are just some numbers that I came up with, and I'm going to show you where these numbers come from. But it would be a great thing that you could do, right? And that would add to the progressiveness to the application, right? It would allow someone with even a very slow connection to still have a very visual experience of your application. Now, the good news is that it is possible to do this today, and I'm going to show you how to do that. And in fact, I'm going to show that to you now, because we're going to do the demos. So what I'll do now is open up my code editor, which I'm hoping you can see. And So let me start with a very basic example. So, I don't know how many of you are familiar with progressive web apps, or how many of you, this is your first sort of interaction with it, or the first time you hear about them. But I prepared a very basic example just to show you the fundamentals of a progressive web app. So I have probably the most basic HTML file that you've seen in your life, where we have a CSS file and a JavaScript file enabled, right? So what I'm going to do is open up an HTTP server, and I'm going to take a look at this file in my browser, which I think I need to bring over to the other screen. And actually, that's not the right file, because I always forget to cd into the right folder. Okay. Right, so what we have here is the H1 message service worker. The reason why it's red, there's a very good reason why I made it red, is because inside our CSS file, I just apply some styling to the H1 element. Okay, and this is exactly what you see here. Now, if I open up my dev panel, my dev tools in Chrome, if I take my network offline, and if I refresh, okay, I forgot to disable this, but I'm still getting exactly the same application, right? So how does it work? Why do I see everything in here? Well, if we take a look at app.js, it's exactly the same couple of lines of code that you saw in the presentation. And in fact, if I open service worker, you will see that this is exactly the same file. Again, something that you saw in my presentation. So let me just remove app.css, and let me come back here and just get rid of everything. Just do a reset in my environment. Done. Okay, so if I'm offline, this is the usual screen that you would see. And as I said, you can play a game if you press space. So just if you want to have fun, it's like a little Mario game in here. But I don't get anything. So let me go online. Let me do a refresh. So now I see my app, it's here. Let me go offline again. And notice that I still see the tag service worker, but it's not, there's no styles applied to it. And this is proving to you that because I did not cache the CSS file, and it's not part of my cache, the service worker can't retrieve it, but it can retrieve everything else that belongs to my application. In fact, if I go to application, which is the tab here that I have in my DevTools, and if I click cache storage, notice that I have a cache called my cache right here, and it consists of an app.js and an index.html. So these two assets are part of my cache, okay? And my application pretty much works offline, right? I don't have a network, but I can still load something, which is a lot different, or it's a very different behavior than what you saw before when I saw the dinosaur and I couldn't do anything. So this is the simplest example that I could have ever come up with. Okay, so let's take a look at some additional examples. And in order to do that, what I'll do is just start up an API. I have a REST API running locally, which I guess I can show you what it does here. So it's localhost 3000/API/news, which returns a JSON structure, which is made up news articles, right? There's a slug, so some text, an image, and when this particular article was added. And I now have an application, and we're going to start with this one. And let me just open up a new terminal window here. And what I'll do is cd into this one. And I think I need to do an HTTP excuse me, server. And there we go, localhost 8080 again. Now, one thing that I want to mention, if you work with service workers, if I just do a refresh, the new application will not show because I still have the old service worker running. So I'm just going to make sure that the side data is deleted. And now I have my new application up here. So it's a made up news portal where you see I have a bunch of news articles, and that's pretty much it, right? So I'm going to zoom back a little bit. You don't really need to read the text. I have a menu here, nothing in there, and I can, of course, click read more. And this is now going to, oh, no, actually, this is not this example, sorry. So it just shows you some news, right? Now, if I refresh, everything works. If I go offline, let's see what happens. So I'm just going to hit offline and refresh this particular application. And notice that even I'm offline, even though that I'm offline, everything works. I have the entire application here, including the news. Now I can't read them, and there's a reason why I can't read them, because that's the next example. But at least I'm showing something to my users. I'm not showing that, no internet and go away from here. Now, if I take a look at the cache, there's going to be a bunch of things that are added. First of all, notice there is a Workbox pre-cache added with a lot of static resources, right? These are all icons, index.html, there's app.js, about.html. So in fact, I think if I go to, where's the about, read more about it here, even I'm offline, that works. That page just loaded, right, without me having a network connection. So the reason why this works is because I'm using, of course, a service worker, but this time around, I'm using Workbox. And again, exactly the same example from my slides. I added pre-cache and root, which meant that I don't need to manually select all the files that I want the cache to have. It's done automatically for me. Furthermore, I also added the API caching. So if I go back to my browser, you will see that there's another cache called the API cache, and it cached /API/news. And if I click on it, well, you can't really see it, but it's in the bottom of this panel here. You see that there are 4 arrays inside, 4 objects inside this array, and each of them is the response from my REST API call, which means I can just very easily serve that up, serve the content up from the cache, even when I'm offline. So this is great, right? This is, we're getting somewhere. So let's take a look at another example, which is going to be this SSR visual queue. So SSR is server-side rendering, and then we, it's just a different example. There's this one. And it's kind of different from the previous examples because it adds a lot of additional things. Now, notice I have a service worker develop a dev file, and there are many ways that you can create service workers using Workbox. Now, what I'm doing here is that I'm building up my service worker file here, and then I run it through a build process, which will automatically generate the full-blown service worker for me, which I can then add to my application. Now, this particular example is very interesting because I'm going to be, again, caching the response from my REST API. But what I do here is I'm using partials, and I have these HTML files for the header, for the hero, and for the articles, and I'm building up my page programmatically using what is called a stream strategy from Workbox Streams. And this will allow me to sort of fine-tune how my application is going to be cached. So I can just cache all these partials. So no matter what, I'm caching the header, the information, the hero, and I'm building up the articles, and I iterate through all of my articles that come back from my REST API. And there's a bunch of other things that I do. I also separately cache the response from the REST API. Now, how is this exactly different from a previous example where, first of all, I'm reusing a lot of stuff both inside my server file in Node.js, because I'm using the same sort of partials to build up my HTML on the server side, and I'm using exactly the same logic to build up my service worker as well, which will result in some very interesting things, which you will see in just a moment. So I need to go online, clear the site data, close this, and just do a refresh. And okay, here we go. So seemingly, everything is the same, right? Except now I can, of course, click read more, and I extended this application so that I can open a single piece of article and I can read that, and I can go back and read others. And also notice we have this read later button. So let me demonstrate what that does. First of all, let's assume we're going to be offline now. Now, notice the difference between this version and the previous version. In this version, I'm saying that if you're offline, sort of make the articles that you can't interact with transparent, right? So I can't click on these because it wouldn't make sense, right? If I would click read more, I would just get no internet because it's not cached. But the article that I actually read is available. So what I do behind the scenes, if someone opens up an article, I place that into my cache. So I can, even when I'm offline, I can just come back and read this article. And this is why I added this read later button. And the use case is the following, right? Let's assume that this is your news application. You're commuting to work, if the pandemic is over, of course, and you know that there's a big tunnel coming up, or you know there's a section in the railroad where you don't have a network connection, and you're going to say, well, before I get to that point, I want to read this article and I want to read this article as well. So you click on the read later buttons. Now, what I didn't add, and I should have, is some sort of a visual or some sort of feedback to the users saying that, good, that article is now added to the cache. And if I now go offline, so we hit that tunnel, and notice that we can read all 3 articles. And just to prove it to you, we'd never opened this particular article, so I can just click read more, and now I can just go ahead and read this entire article, right? It's that easy. And I'm giving some very good visual indicators to my users as to what they can and what they cannot do when using my application. And believe it or not, when you click on read later, what happens, you can also programmatically add stuff to the cache on certain user action. So if we look at the cache storage, you will notice that the API cache not only contains /API/news, which is the response for all the news, but it contains 1, 3, and 4, which are the articles where this is the article that we opened, the first one, and then 3 and 4 are the articles where I clicked read later. So I'm programmatically adding the content to my cache, which then allows me to serve up that content even without a network connection. So let's take this to the next level. Let's take a look at the next example, which is media progressive. So it's going to be exactly the same stuff, but let's go online. Let's clear everything. Again, starting from scratch, and let's refresh. And again, we have the same example, except we now have media assets, and this is now pretty much how a news site would look like, right? So now if I say I'm really interested in baseball, and I know again the tunnel's coming up, so I'm just going to hit read later. I will then go offline, and if I hit read later, read more, then notice that I see everything, including the image. So even the image is added to my cache. And if I go to the application panel here and take a look at the cache storage, I now have an API cache. I have the Workbox pre-cache, which are all the static assets, and I have Cloudinary images, because Cloudinary is is the place where I store my images, and these are all the image assets that I have, which I now have also as part of my cache available for me offline. But it's not a cache, but there's some additional things happening behind the scenes which you may not realize. So let me do a quick demonstration of something for you. And this is now related to the slide where I talked about the different quality images based on the network connection. So I'm using Cloudinary, which is a cloud-based provider that allows you to store your media assets, your images and videos, and they have a CDN, which then also allows you to distribute those. Furthermore, they allow you to optimize and transform your images. Now, let's assume we uploaded this particular image to Cloudinary, and then we got this access URL. Now, I realize that's very small, so let's do it this way. I'm just going to put it in here. Okay, so something, my account name, image upload, name of image, .jpg. And if I open up my network panel here, you will realize that this is, in fact, if I just refresh this, this is a JPEG image, that's the content type, and it is 583 kilobytes in size. That's great, but I consider that to be a heavy image in terms of the kilobytes. Let me add one thing here, which is going to be f_auto. I'm just modifying the URL here. So f_auto is short for automatic formatting. What will happen now if I open this URL? Cloudinary is going to take a look at the browser that I'm using. It will realize that this is Google Chrome. It knows that Chrome browsers can support WebP images, so that's web picture, WebP, and they're going to generate a WebP on the server side, and they're going to serve that up for me automatically. And I didn't change anything here, right? So I'm just going to hit enter. And notice that now the size is just 49 kilobytes. The quality of the image is exactly the same, but because we're using a different format, which is image WebP, I managed to save 400, 300, or 400 or some kilobytes, which is great. Furthermore, if I just jump back here, I can add another flag, which is Q_auto, right, which is short for automatic quality. Now, images contain a lot of noise, extra pixels, which, if you look at it with your human eyes, if you drop them, it's not going to make a difference. In fact, by adding this Q_auto, Cloudinary will remove all the unnecessary pixels and unnecessary data from the image in a way that we're not going to lose what is referred to as visual fidelity. Visual fidelity is, if you lose a lot of visual fidelity, it's a very blurry, pixelated image. So I'm just going to hit enter here. You don't see a reduction in quality, but you see that now we are at 32 kilobytes in size. So again, the size just gone down. Now, why am I showing this to you? The reason why I show this to you is because Q_auto has some flags. And for example, I could do Q_auto low. So this is going to render a 25 kilobyte image. Or if I do Q_auto good or best, this is going to create a 49 kilobyte image. So using that flag, I can sort of fine tune how much quality I want to how much quality reduction I want to do. And this is the point where we're going to bring in the network connection speed of the user. So let me show you that in code as well, which is inside our service worker. So I created a plugin for Workbox, but just to, and I was doing some testing here, but just to keep things simple, I moved all the code inside here so that I can go through that now. So Workbox, let's just close that. So Workbox allows us to create our own plugins, our own logic that we want to add. And what I do, I'm registering a root, and I say if the origin of my request is res.cloudinary.com, meaning it's a Cloudinary image, I want to create a cache called Cloudinary images. I only want to cache, 200 OK images. And notice that I'm also using something that is called a Cloudinary plugin. Now, cacheable response plugin, expiration plugin, stale while validate, these are all workbox, these are all built-in workbox, classes and methods that I'm accessing here. Cloudinary plugin, on the other hand, is my own custom plugin, which is written right here. So what I do here, I say, if the image is a JPEG, or I'm basically saying if it's an image, testing the URL of the request, I'm going to split that up into parts. I'm going to enforce fauto, and then I'm going to switch to the Network Information API. The Network Information API is one of the latest web APIs that allows you to take a look at the network connection speed of your user. And it is available via navigator.connection.effective-type, right? So I can take this, I can go to my DevTools console, and I can just type it in here, and this is going to return 4G. And the possible values for this is 4G, 3G, 2G, or slow 2G. And notice that what I do, I'm going to append QAutoGood, echo, or let's also do best, echo, low, and the default is best here. And I essentially take that Cloudinary URL, I split that into parts, I'm looking at the network connection speed, and I reconstruct the URL with the new parts and fauto edit to it. And that's the new request that I send via the service worker. So this is a classic example when the browser makes a request for my images, I stop right there, do my work, update the request, and send the new request to the browser. So let me save this. And I think I need to, because I made a change, build. Build. I need to rebuild my service worker. Oh, good. Maybe we won't do that live now. Why is this build.js? Doesn't matter. Let's not do that now. It's going to work anyway. So what I'll do, I just fire up the server again. And now that we know this, let's do a couple of tests. Let me just clear everything from the storage. Oh, it's not this one. It's this one. Storage, clear site data. Go online. Go back to the main page, and let's open up our cache. Cloudinary images. Now, let's focus on the first image, right? So this is the request to the image. First of all, you see there's no QAuto and there's no fauto inside this image. And the image size is 69 kilobytes. Let's, for the sake of this demo, let's say that's 70 kilobytes, okay? And what I'm going to do, I'm going to say, well, someone is now going to open up this page on a slow 3G connection. So I'm going to go back to here and hit refresh. And notice that the images, that the size of the images have went down. It's now 50 kilobytes. And if we take a look at the request URL for these images, which you can do via the network panel EMG, the actual requests, why can't I see the actual request? Am I filtering for something? Anyways, the actual request got updated because you saw that the size went down from 69 to 50 kilobytes, from 70 to 50 kilobytes. And if I do fast 3G, for example, then of course I'm again getting a different file size because I'm applying a different QAuto, a different quality reduction. And what I have achieved here is basically still giving my users a very visual experience, even if they have a slow network. I can basically serve an image for them, which is lower in quality, but it's still something that I can do. And of course, if someone is now online, so they have the full-blown Wi-Fi fast internet, then I can serve the highest quality of images for them. And everything will still work offline using whatever image they have in their cache. And then the last example that I'd like to show you, because that usually comes up as well in different conversations with people, and that's the facts about videos. Can you cache a video? And the answer to that is yes, you can. So I'm going to go back one level, and I think I can just do a no HTTP server. Usual port, so I need to clear this and come online. And now this is going to be just a very simple demo where we have a video. You get a bonus point if you figure out the location of this video, right? So I can play this video. Everything is fine with this. And I can now go offline, refresh the page, and I still get the video. All right, I added a red CSS just to show you that, again, this is offline. And I can still play. I can even go to the parts of the video that I haven't been to, right? Because the whole video has been cached. Now, obviously, you don't want to cache gigabytes of video because I usually get a question around the cache sizes. Different browser vendors on different operating systems, based on your machine's capabilities in terms of the HDD capacity, would so all of these factor into how much data you can put inside your cache. So you have to be mindful of that. Now, one interesting thing that you can do, and let me just show this to you as the last thing. So if we open this particular video here, so this video, again, as I said, Cloudinary does images and videos. So this is video. Cloudinary also allows you to sort of modify the video on the fly. So notice this has a video, a width of 800. So I could just do 400. Save this, and this is now going to, if I of course go back online, this is now going to generate a much smaller video. If I of course remove my service worker first, like so, this is now going to generate a much smaller video, which is going to be with 400 now. Furthermore, I mentioned progressive enhancements, right? So think about your users. If someone is on a 2G connection, a 3G connection, loading this video may not work for them. Now, what I'm going to do is just show this to you real quick here. What Cloudinary allows you to do is to replace the extension of your video with, say, JPEG. I'm just going to copy this and add this to my browser. And believe it or not, what Cloudinary does, they just grab the middle frame and serve that up. Again, if you want to change the width, we can do width 1200, and this is now going to be a much larger image for us. And this is a still, right? And you can specify which frame you want from the video. Consider the fact that someone is on a 2G device or a 3G network, and instead of serving up a video for them, you could just serve this particular image for them. Again, using the network information API, you could just very simply update this particular call with JPEG instead. Of course, move it to an image element as opposed to just a video element. So there's a lot of things that you can do, which would play along well with the term progressive. Okay, I think I showed you everything. There's one more video that I'm going to show you, a bunch of resources that you can take a look around, progressive web apps, etc. As I said, we'll try to find a way to share the slides with you so that you can actually click on these and then go to the appropriate URLs. And last but not least, I don't want to take up a lot of your time. I just prepared a video to show you how the news application would behave on a mobile device. So here's an iOS simulator. I go to open up the browser, go to the news website, which is localhost 8080. I can read more and do stuff, and then I'm going to click on this icon and click on Add to Home or Add to Home Screen, and you can do this on Android and iOS as well. Notice the icon, and now it looks like an application. I can interact with it, and it's going to just behave like any other application on my device. There's no way that you can tell if this is an actual web application which acts as a progressive web or a purposefully created iOS application, right? And this is, again, something that progressive web apps allow you to do. And as I said, there's bunch of other things like notifications and others. Okay, and with that, thank you, or I'm sorry, obrigado for your attention. Thank you very much for joining me. And I think we can open up the stage for questions, or if there were any questions, I would be happy to answer them. I think you're on mute, Rustin.
I did the classic classic thing. I think it's this year. It's like you're on mute kind of thing. Thank you.
Yep.
Thank you for the great presentation. It was really, really good. It was really interesting to learn some new tricks and see how things work. Yeah, so the questions are, feel free to ask the questions in the chat window on YouTube. And while we're doing that, I see some questions coming in, and I have another question myself. So
sure.
If you, well, 3 main things you want people to kind of think about when they develop PWA, so progressive web apps. 3, just because, I don't know, people like this 3 things something, right?
So what would be the 3 things to...
3 important things. I mean, when people start working with progressive web apps, what should they, like 3 of the most important things that they should kind of remember or take care of, or, do?
Sure.
Especially compared to like regular web development, right?
Yes, I think the one point that I wanted to say first is also relevant to normal web development, and that is test regularly on slow hardware. So don't assume that everyone runs on the runs around with the latest iPhone, maxed with the largest screen. Take people into consideration who have an older Samsung device, for example, right? So both in terms of the hardware capacity, both in terms of also sort of realizing where your users are. So I just as a side note, I had the opportunity to attend a conference when when airplanes were up in the sky in Asia, and there was this developer who talked about a big transportation company that I won't mention now, that came to that country. The country is India, and the business was not booming. They didn't get that many rides as they anticipated. And then this lady who was doing the talk showed a video of that site loading in her area, and it took about 1.5 minutes for the entire thing to load. Now, how can you expect people to use your service if they can't see anything on your site for like a minute, right? So do take everyone into consideration. Another point would be, before you jump into using Workbox, because I kind of drank the Workbox Kool-Aid here because I really like it and I enjoy working with it. Stop yourself and do get familiar with the Service Worker API and the Cache API, because you need to understand how those work in order to be able to effectively utilize the power of Wokbox.js. I guess that's the most important thing to do, right? So learn the foundations, play around with the service worker, try to find an edge case that you don't know how to solve. And when you're at that point, you will know that the next natural step would be to use Wokbox.
That makes sense. That's a very good point. Thank you for that. So there are a few questions that are coming in. So the first one, I'll read it for you. Well, you see it on the screen as well. Is it possible to do CRUD with a database when the app is used offline? If yes, how it works in terms of synchronization?
Sure. Yes, it is possible. And I have I don't think I can show it now, but because I don't think it's working. But I had this app, or I still have it somewhere, which it allows you to take a picture using your webcam, even if you're offline. And if you're offline, what happens? I store the data object that I want to store in the database inside. I think I'm storing it in local storage or maybe in the cache. I can't remember now. And I think there's an event listener you can listen on inside JavaScript, which is the online or offline. And so what I did, I said, if you change the state from offline to online, the first thing that I do is do this synchronization, right? So you can do that. Now, of course, it depends on what kind of application you have, how you manage, all the synchronization otherwise. But there are some strategies that you can do, right? So you would, if you're offline, store everything locally. If you go online, fire up an event, go through the things inside maybe local storage or wherever it is, upload it to your database, store it in your database, and then clear that storage, and then you're pretty much done.
That sounds good. So basically you implement the logic or do the implementation of the synchronization yourself, right?
Correct.
Yeah.
Maybe there are tools out there. If you find one, then please let me know, because I would love to know about it as well.
Yeah, sounds good. That's great. Thank you. Oh, there is another question. Nice. How much content can we put into cache, and for how long, or for long videos, for example, does it work?
Okay, so I think I kind of mentioned this during the presentation. So it's going to be dependent on a number of factors, the size of the available cache, and that is the actual hardware that you use, your hard disk, the operating system that you use, and the browser that you use. And then different browser vendors with different versions would have different logic for the cache. So there's no definitive answer. So I can't tell you that you're good for a gigabyte of videos, because it may be true for some devices, it may not be true for others. I would say, with videos especially, do exercise some caution. Videos are kind of tricky to cache anyway, because the way browsers request videos is by using the partial gets. It's just not, your browser is not executing an HTTP get. It executes like a partial HTTP get, which has this header and a code of like 206, so HTTP 206, I think. So it basically requests ranges from 0 byte to 500 bytes, and then 500 to 1,000, and that's how it builds it up. For smaller videos, you're not going to run into problems, but as I said, don't try to cache a 4K 1-hour video, because it's likely it may work on your device. Like it will work on my device, but it may not work on an actual mobile phone. Exercise caution in there, right? It's not a big deal for API responses or for images, but even with images, you have to be careful, right? That's why I was showing you this Wokbox plugin about how many entries you want to have in there. What's the age of those, so you get this nice rotation of never filling up your space in cache.
That makes sense. It's I guess the the advice is the same that you mentioned earlier. Keep in mind the different, like, huge amount of devices that are out there, and some of the devices will probably, I don't know, even implode or melt or something trying to catch for 4K video.
Yeah. Another thing, just something that popped into my mind is, and that's based on the last thing that I showed you. Like, maybe you have a video. Just think about it. Is it absolutely necessary to show the video when someone is offline? Maybe it's just enough to replace that video with an image, and you cache that image, right? So think about it, where I showed you how you can just in Cloudinary change the extension, and then think about it when you add your static assets. You just say, here's a video, change that extension to a JPEG, cache that JPEG, and then have some logic in your code that says, hey, if you're offline, don't show the video, just show the image. So you still provide some visual elements to your users. That's another scenario that would save up your cache and give a relatively good experience for your users if they are offline.
Yeah, that sounds reasonable. That's a very good. So I think we have time for one more question, and it came just in perfect. That's a bit more generic question, I guess. Your Visual Studio Code
Yeah.
So what is the plugin that you're using to create those funny terminals in Visual Studio Code?
It's a super secret plugin. I developed that my own, so it's not a plugin. I'm using ZSH, and I'm using the what is it? The Oh My something something, which allows you to create plugins. So I just extended the default theme that I have, which is I think called the Rob Russell or something Russell theme. People who used ZHS would know that. And I just added an array of emojis, and then every time when the terminal fires up, I get a different one. And then I added some additional logic that if it's a special day like Easter, New Year's, Christmas, it always shows like a Christmas tree or a Halloween pumpkin or an Easter bunny.
Nice.
It's just something I did myself.
Have you tried integrating it in with what's it called? Isn't it called Cow Says or something? Cow Say? There is like a command line tool where you can just say cow say and whatever, and it will show it ASCII cow. Saying whatever you ask it to say, and then there are like different options for different animals and stuff.
No, this, trust me, it took sufficient amount of time to figure this out. So I thought that's the maximum amount of available time that I have on that.
So I guess next question will be like, when are you going to open source it?
Yeah.
Oh well. That sounds like fun. Sounds like really fun. Thanks to do and to play around with command line and stuff like that.
Yeah.
So I think that's all the questions that we have time for now. But I guess people will be able to get hold of you on social media, on Twitter, and some other places.
So I don't know if we can share. Yeah, that's my slide again.
Yeah.
So that's my Twitter handle. So my DMs are open. Feel free to get in touch about progressive web apps or anything else for that matter. Even the emojis, I'm happy to answer any questions about emojis. So you can find me on Twitter with that handle.
Fantastic. So yeah, thank you very much for doing that, and thank you for being a part of GDG Tech Sessions. It's
Thank
been
you for
great
having me.
having you.